Your immune system is working right now. Millions of cells inside your body are patrolling, detecting, and destroying threats you will never even know existed. Bacteria, viruses, abnormal cells. Your immune system handles them all every single day. But here is something fascinating. There is a simple, free, and scientifically proven way to make this defense system even stronger. Something humans have been doing for thousands of years, often without understanding why it worked. That method is fasting. Before we go any further, this is educational content, not medical advice. If you have any health conditions or take medications, talk to your doctor before trying any fasting protocol. In this video, we will explore exactly what happens inside your body when you stop eating, and why not eating might be one of the most powerful things you can do for your immune health. Let us start by understanding what we are actually trying to strengthen. Your immune system is not a single organ. It is a complex network of cells, tissues, and organs working together to protect you. Think of it as a fortress with multiple layers of defense. The first layer is innate immunity. This is your body's rapid response team. It reacts immediately to any invader, regardless of what it is. Your skin, the mucus in your nose, fever, inflammation. These are all part of innate immunity. It is fast, but not specific. It treats every threat the same way. The second layer is adaptive immunity. This is your specialized defense force. It takes longer to activate, usually several days, but it has a remarkable ability. It remembers. Once your adaptive immune system encounters a specific pathogen, it creates a memory. If the same threat appears again, your body responds much faster. This is why you usually only get chickenpox once. Both layers need to work together for optimal protection, and both can be influenced by how you live. Here is the problem. Modern life is not kind to our immune systems. Chronic sleep deprivation suppresses immune function. Constant stress floods your body with cortisol, which over time weakens your defenses. Diets high in sugar and processed foods create chronic inflammation. Lack of physical activity reduces the circulation of immune cells. Many people are walking around with immune systems that are overworked, underpowered, and prematurely aged. So the question becomes, is there a way to reset this system to clear out old damaged components and allow your body to rebuild its defenses fresh? This is where fasting enters the picture. And the story begins with a simple observation from nature. When animals get sick, they do something counterintuitive. They stop eating. Dogs, cats, horses, elephants, even fruit flies. Across the animal kingdom, sick animals refuse food. Scientists call this sickness-associated anorexia. For a long time, doctors assumed this loss of appetite was just a symptom, something to overcome by forcing sick patients to eat. But researchers started asking, what if this is not a symptom? What if it is a treatment? The ancient Greeks noticed this pattern thousands of years ago. They observed that humans, like other animals, naturally lose appetite when sick. They called it the physician within. Hippocrates wrote that to eat when you are sick is to feed your sickness. He believed fasting gave the body space to fight infection. Now modern science is confirming what Hippocrates intuited. This instinct to stop eating during illness is not a bug in our biology. It is a feature preserved through millions of years of evolution because it works. But how does it work? What actually happens inside your cells when you stop eating? The answer lies in a process called autophagy. This word comes from Greek and means self-eating. But do not let the name alarm you. Autophagy is one of the most beneficial processes in your body. Your cells constantly accumulate damage. Proteins become misfolded. Mitochondria, the tiny power plants inside your cells, become dysfunctional. Bacteria and viruses can hide inside cells. Over time, this cellular debris builds up. Autophagy is your body's cleaning system. During autophagy, your cells identify old, damaged, or dangerous components, break them down, and recycle the raw materials to build new, healthy components. Here is the key point. Autophagy is regulated by nutrient availability. When you eat especially carbohydrates and proteins, insulin rises. High insulin activates a pathway called mTOR. When mTOR is active, it tells your cells to grow, but it suppresses autophagy. When you stop eating, the opposite happens. Insulin drops. mTOR becomes less active. Autophagy gets switched on. This is why eating constantly, always snacking, keeps autophagy suppressed. Your cells never get the chance to clean house. In 2016, Japanese scientist Yoshinori Ohsumi won the Nobel Prize for his discoveries about autophagy. This was Nobel Prize-winning research confirming that cellular cleaning is fundamental to health. For your immune system, autophagy plays several critical roles. It can directly destroy bacteria and viruses hiding inside cells. It helps present pieces of invaders to your adaptive immune system, training your defenses to recognize threats. It removes damaged mitochondria that can trigger harmful inflammation. So fasting activates autophagy, and autophagy strengthens immunity. But the story does not stop there. In the first 0 to 12 hours after your last meal, your body is still processing food. But as hours pass and no new food arrives, insulin begins to drop. As insulin falls, something interesting happens with inflammation. There is a protein complex in your cells called the NLRP3 inflammasome. It acts as a sensor and alarm system. When it detects danger, it triggers inflammation. Useful in acute situations. But when constantly activated, it creates chronic inflammation that damages tissues and wears down your immune system. Fasting begins to quiet this alarm system. Research from the National Heart, Lung, and Blood Institute in 2024 discovered that during fasting, a fatty acid called arachidonic acid increases. This arachidonic acid directly inhibits the NLRP3 inflammasome, turning down unnecessary inflammation. Your body also releases cortisol during fasting. In this context, it is actually helpful. This cortisol helps control inflammatory cascades, working similarly to anti-inflammatory medications. Interestingly, dexamethasone, a drug doctors use to treat severe infections in intensive care units, works through a similar mechanism. Your body is producing its own natural version of this protection. By the end of this first phase, your digestive system begins to rest. The energy normally devoted to breaking down and processing food becomes available for other purposes. Your body is preparing for what comes next. Between 12 and 24 hours, your body makes a significant metabolic shift. Glucose stored in your liver runs low. Blood sugar drops, and your liver begins producing ketone bodies from fat. This shift has important implications for fighting infection. Bacteria love glucose. They depend on it to grow and multiply. Your cells can use either glucose or ketones for energy. But most bacteria cannot efficiently metabolize ketones. When you fast and your body switches to burning fat and producing ketones, you cut off the food supply to bacterial invaders while your own cells continue functioning normally. You are starving the enemy while feeding yourself. This is one reason why loss of appetite during infection may have evolved. By naturally reducing food intake, your body automatically shifts into this pathogen-starving state. Evolution selected for this response because it helped our ancestors survive infections. Research has also shown that linoleic acid, which increases during fasting, can bind to certain sites on some viruses, potentially reducing their ability to attach to your cells. Scientists have discovered that some viruses have pockets on their surface where linoleic acid can fit, and when it does, the virus becomes less effective at latching onto human cells. This metabolic state, running on ketones instead of glucose, also provides a cleaner fuel for your brain and other organs. Many people report increased mental clarity during this phase, which makes sense from an evolutionary perspective. Our ancestors needed sharp minds to find food when they were hungry. Between 24 and 48 hours, something remarkable happens to your immune cells. A 2023 study in the journal Immunity made a surprising discovery. During fasting, monocytes, a type of immune cell, retreat from your bloodstream back into your bone marrow. Monocytes are critical components of innate immunity. They patrol your blood, detect invaders, and can transform into macrophages that engulf and destroy pathogens. They are among the first responders when infection strikes. You might think having fewer of them circulating in your blood would be a bad thing. But the researchers found something interesting. The bone marrow acts as a safe haven. During nutrient scarcity, it protects monocytes from damage. They are not being destroyed. They are being preserved. This is an energy conservation strategy. Immune cells are metabolically expensive to produce and maintain. When food is scarce, your body protects its investment by sheltering valuable immune cells ready to deploy when conditions improve. The signal for this retreat comes from the brain. The hypothalamic pituitary adrenal axis, which connects your brain to your hormonal system, releases corticosterone. This hormone increases a receptor on monocytes called CXCR4, which guides them back to the bone marrow. It is a coordinated, intelligent response, not random cell death. Think of it as pulling your troops back to a fortified position during a time of resource scarcity, keeping them safe and ready for the next battle. Between 48 and 72 hours or more, we see perhaps the most dramatic effect of extended fasting on immunity. This is where research from the University of Southern California becomes particularly relevant. Professor Walter Longo and his team at USC made a discovery that surprised even them. In both mice and a phase 1 human clinical trial, they found that cycles of prolonged fasting did not just rest the immune system, they regenerated it. Here is what happens at the cellular level. When you fast for extended periods, an enzyme called pKa decreases. pKa normally keeps stem cells dormant. When pKa drops, it gives stem cells the green light to wake up and start working. At the same time, IGF-1, a growth factor hormone, also decreases. This combination triggers hematopoietic stem cells in your bone marrow to begin dividing and producing new immune cells. The hematopoietic system is the system that produces all your blood cells, including every type of immune cell. Red blood cells, white blood cells, platelets. They all come from hematopoietic stem cells in your bone marrow. Professor Longo said, quote, "We could not predict that prolonged fasting would have such a remarkable effect in promoting stem cell-based regeneration of the hematopoietic system." End quote. In other words, prolonged fasting can trigger your body to break down old damaged immune cells and rebuild fresh ones from stem cells. It is like pressing a reset button on your immune system. The study showed that fasting could generate, in Longo's words, literally a new immune system. This has profound implications. As we age, our immune systems become less effective. This process, called immunosenescence, is one reason older adults are more vulnerable to infections. If fasting can stimulate the regeneration of immune cells from stem cells, it may offer a way to partially reverse this age-related decline. When you break your fast, monocytes, sheltered in the bone marrow, surge back into your bloodstream. They are rested, preserved, and ready for action. This is why breaking your fast properly matters, which we will discuss in the practical section. Beyond autophagy and stem cell regeneration, fasting provides several other immune benefits. First, reduction of chronic inflammation. Studies on Ramadan fasting show reductions in pro-inflammatory cytokines, including interleukin 1 beta, interleukin 6, and tumor necrosis factor alpha. A 2024 meta-analysis found that time-restricted feeding significantly reduced TNF-alpha and C-reactive protein. Lower chronic inflammation means your immune system can focus on real threats. Second, fasting affects lymphocytes, the T cells and B cells that form the core of adaptive immunity. Research suggests periodic fasting helps refresh your lymphocyte population, clearing out older cells and making space for newer, more functional ones. Third, there is the gut microbiome connection. Roughly 70 to 80% of your immune system resides in and around your gut. Studies show intermittent fasting can positively alter gut microbiome composition, increasing bacterial diversity and promoting beneficial bacteria. A healthier gut microbiome means better immune regulation. Now let us look at clinical evidence. Does this translate to better outcomes when people get sick? In 2022, researchers at Intermountain Healthcare in Utah published a study on patients who tested positive for COVID-19 during the pre-vaccine era. Among these patients, some had practiced periodic fasting for religious reasons. In Utah, many people fast once a month, skipping 2 consecutive meals. Researchers compared outcomes between those who fasted regularly on average more than 40 years and those who did not. Among regular fasters, 11% required hospitalization or died. Among non-fasters, 28.8% required hospitalization or died. That is less than half the rate of severe outcomes in the fasting group. Importantly, fasting did not prevent infection. Infection rates were similar, but fasting was associated with dramatically less severe illness. The researchers proposed several mechanisms: reduced chronic inflammation, enhanced autophagy, clearing infected cells, and the metabolic conditioning from years of periodic fasting. Other studies show similar patterns. Research on Ramadan fasting showed significant reductions in inflammatory cytokines. A multi-omics study after 72 hours of fasting found dramatically increased autophagy in white blood cells. So we have the science and evidence. Now let us talk about practical application. There are several approaches to fasting. The most accessible is time-restricted eating, the 16-8 method. You eat within an 8-hour window and fast the remaining 16 hours. For example, eat between noon and 8 p.m. Since you sleep for half the fasting period, this is manageable for most people. It lowers insulin, activates some autophagy, and begins reducing inflammation. The 5-2 method involves eating normally 5 days and restricting calories to about 500 to 600 on 2 non-consecutive days. This creates deeper metabolic stress that enhances fasting benefits. A 24-hour fast, done once a week or month, takes things further. Eat dinner, skip all meals the next day. Eat dinner the following evening. This puts you solidly into ketosis and significantly activates autophagy. Extended fasts of 48 to 72 hours or longer are where stem cell regeneration research becomes most relevant. However, these carry more risk and should only be attempted with fasting experience and ideally medical supervision. If you are new to fasting, start with 16-8 for at least 2 weeks. Pay attention to how your body responds. Once comfortable, you can experiment with occasional 24-hour fasts. Regardless of method, certain safety practices are essential. Stay hydrated. Drink at least 2 to 3 liters of water daily. You can have black coffee and plain tea. For fasts longer than 24 hours, consider supplementing electrolytes. Sodium, potassium, and magnesium become depleted. A pinch of salt in water or an electrolyte supplement can prevent headaches and fatigue. Listen to your body. Mild hunger, slight fatigue, and occasional irritability are normal when new to fasting. But certain symptoms mean you should stop immediately. Severe dizziness that does not pass after 30 minutes. Heart palpitations or irregular heartbeat. Confusion or difficulty thinking clearly. Extreme weakness, nausea or vomiting. If you experience any of these, break your fast immediately with something gentle and consult a healthcare professional. How you break your fast matters. After extended fasting, your digestive system has been resting. If you immediately eat a large, heavy meal, you can overwhelm your system. Start with broth, a small portion of easily digestible food, plenty of fluids. Wait an hour or two before a full meal. Certain people should not fast or should only fast under medical supervision. Pregnant or breastfeeding women have increased nutritional needs. People with eating disorder history should approach fasting very carefully. Anyone taking insulin or diabetes medications needs medical guidance. People with chronic kidney disease, those who are underweight, and anyone under 18 should not fast without supervision. One more important point. Fasting is most beneficial for immune support when done preventively, before you get sick, or between illnesses to maintain defenses. If you are currently fighting an acute infection, especially a severe one, consult your doctor before fasting. So where does this leave us? The evidence is compelling. Fasting practiced safely and strategically appears to be a powerful natural tool for supporting immune function. It activates autophagy, your cellular cleaning system. It reduces chronic inflammation. It can trigger stem cell regeneration. It starves pathogens while your cells adapt. And it gives your body the metabolic reset that modern life rarely provides. This is not a magic cure or replacement for vaccines, medications, or medical care. But it is a tool humans have used for thousands of years, that nature programmed into our biology, and that modern science is now validating. The ancient Greeks called the fasting instinct the physician within. They may have understood something we are only now fully appreciating. If you want to start, here are concrete steps. First, start with 16-8 time-restricted eating for 2 weeks. Second, pay attention to how you feel. Third, if you feel good, try extending your fasting window occasionally or adding a 24-hour fast once a month. Fourth, always prioritize hydration and electrolytes. Fifth, combine fasting with other healthy practices, adequate sleep, stress management, regular activity, and nutritious eating during feeding windows. The long-term benefits extend beyond immunity. Regular fasting has been associated with improved cardiovascular health, better metabolic function, and increased longevity. In a world where new health challenges emerge constantly, a strong immune system is more valuable than ever. Your body already knows how to protect itself. Sometimes the most powerful thing you can do is get out of its way and let it work. Which part surprised you most, that immune cells retreat to bone marrow during fasting, or that fasting can regenerate your entire immune system? Let me know in the comments. If you have ever instinctively lost your appetite when sick, share your experience in one word below. If you found this helpful, share it with someone who might benefit from understanding the fasting immunity connection. Subscribe so you do not miss our next deep dive into how your body works. Thank you for watching. I will see you in the next one.